Okay, let's talk chi-squared test for independence now. We have talked the goodness of fit test, and that is a test that's designed when you have one categorical variable, and the test for independence is when you're comparing two or more variables and you're trying to determine whether or not they are dependent or independent of each other. And so let's take a look. Here we have a contingency table. It's a 2 by 2 table. There's two rows and two columns. And the reason it's a 2 by 2 is because you don't include the sum. The sum is just helping you understand how many total people you're talking about in this case. But if they are independent of each other, that means they have no effect. Gender does not affect whether or not somebody is exercising regularly. If they're dependent of each other, then that means that the gender does actually affect whether or not they regularly exercise. So, for chi-squared test of independence, to calculate it, we need to calculate what is expected. And just like in our goodness of fit, we had to use our theoretical probability to do that. Well, same concept here, but now we have multiple variables, and so we have to make what we call an expected frequency table. When we're talking about identifying our H sub O and our H sub 0 and H sub 1, our null hypothesis is that they are always going to be independent. The alternate hypothesis would be the opposite of that, which means that they would be dependent. So whatever the variables are, your H sub 0 will always be that they are independent. Your H sub 1 will always be that those variables are dependent. Okay, so how do we get this expected frequency table? Well, what you're going to end up doing is you're basically finding that probability that, for example, for this area right here, what is the probability that these were independent of each other for a male to regularly exercise? And to do that, you're going to take, and because we learned about independent, if variables were independent, the probability of A intersect B is the probability of A times the probability of B. We knew that, and so we've learned that. So to find that, what you're going to do is you're going to take the probability of a male, which is 216, times the probability of exercising, and then we need to find the probability of that, so then that's why we are dividing it by 400. So to find that yellow box, we are going to take 216 times 208 and divide it by 400. The next one, if we do let's go orange, the orange is going to be our 216 times 192 divided by 400. If we do female exercise, well, the total amount of female is 184 times the total amount of regular exercise is 208 divided by 400. And then the last one, our blue, is going to be total female of 184 times total of no exercise is 192, and you divide that by 400. So when you do that, you end up getting, for each of those, what we would call an expected value. And that expected value is going to be helpful when we go and find our chi-squared test for independence on whether or not they are independent of each other. So let's remember our chi-squared test when we are observing, or when we are comparing our observed values between our expected. This has not changed. This is the same test as the goodness of fit test, but the goodness of fit is done a little differently because it is a one categorical variable, where this we have more than one category here. And so we have our observed minus our expected squared divided by our expected, and it's the sum of all of those. That's what's going to give us our chi-squared calc value. Okay, so if variables are independent of each other, then the chi-squared calc value will be very small. If they are not independent of each other, which means they are dependent, then that chi-squared calc value will be large. So If they are dependent, it's large. If it's independent, it's small. So let's review our steps here. Step 1 is not any different. You're finding your H sub 0 and H sub 1. Step 2 is not different. You are finding your significance level, which again will be given to you. Step 3, however, because we have more than one variable, to find our degrees of freedom is going to be a little bit different. What you're going to do is you're going to take your number of rows minus 1 times the number of columns minus 1. And whatever you get, that is going to be your degrees of freedom. And then you will either use your p-value or your crit value, depending on if they give you your crit value or not. If they do not give you a crit value, because you do not have to memorize that table, which is the same table as previously, then you have to use your p-value because you don't know your crit. But we're going to calculate it, and it's going to be a little bit different on the calculator, but I'm going to show you how. But that's step 4. Actually we got to construct our expected frequency table and then calculate our chi-squared calc. And then we'll use that p-value or our crit to determine if we are going to reject H sub 0. And just a reminder, if p is less than alpha, then we are going to reject, and if chi-squared calc is greater than crit, we are going to reject our H sub 0. Okay, so let's take a look at this. So here's our observed, which is the original piece, and remember the only ones that matter are the sum part only helps you find the expected, and I have already gone through and typed in our expected values, but if you remember, like that 112.32, that was found by taking the 216 times 208 divided by 400. So on that previous slide, this part right here, this is 112.32. That's what this value is equivalent to. So I've calculated all of those, and that's what those values are. Okay, so now let's state it says find chi-squared calc with a significance level of 5%. Okay, so our H sub 0, well, we're comparing gender versus exercise. So H sub 0, remember, is always that they are independent. So gender and exercise are independent, and H sub 1 would be that gender and exercise are dependent. Our alpha, well, our significance level is 5%, so it's 0.05. Our degrees of freedom, remember, it is row minus 1 times column minus 1. Well, rows run horizontally, columns run vertically. So I have 2 rows and I have 2 columns. So my rows is 2 minus 1. My columns are 2 minus 1. So that's 1 times 1, which is 1. So my degrees of freedom is 1. Our p-value we will find when we actually run our calculator. But our chi-squared crit value, well, we just found our degrees of freedom was 1, and our significance level was 0.5. So if you remember, these are the two things that you need. And if we look at our table, so we had a degrees of freedom of 1 and 5%, which means our crit value is 3.84. So if we go back to that page, our chi-squared crit value is 3.84. Okay, so now we need to go to our calculator, and whether you have an 84 or an 83, you can do this. And the first thing we have to do is put our observed and expected tables, the parts that I have highlighted blue, is what is going to be put into the calculator. So first thing we have to do is go to our matrix, and that means you're going to hit second and then go 4 buttons below the second. It's x to the negative 1, and it's the matrix, so you're going to hit enter on the matrix. And we need to edit matrix A and B. So scroll over to edit and have the A highlighted, the number 1, hit enter. And the first thing we have to do is tell the calculator what size. Well, it's a 2 by 2 matrix, row by column. And then we're going to type in our observed first. Your observed you want in A, and your expected will be in matrix B. So 110, hit enter. 106, you got to go across, hit enter. 98, enter, 86, enter. So matrix A we have made into our correct observed matrix. So now we got to repeat that process for B. So you're going to go second and then hit that x to the -1 to get your matrix, and then scroll over to edit, but then you have to scroll down to B. So scroll down to matrix B and hit enter. We have to change the size. It's a 2 by 3, so or 2 by 2, excuse me. So you hit 2 enter 2. It'll adjust the size, and then we have to enter in our values. So 112.32, enter. 103.68, enter. 95.68, enter. And 88.32, enter. Okay, so if you guys want to go second mode, that'll get you out of that matrix. And now what we need to do, because we're doing a test for independence, all of you on your calculator, you'll go stat and you're going to scroll over to test, just like we did the goodness of fit test, and scroll down, and you are going to see right above the GOF test, it just says, it shows on your calculator chi-squared test. So it's not the GOF, it's just the chi-squared test, and those of you on an 83, you have this. So you hit enter. Your observed, remember we put as matrix A. Your expected was matrix B. So then you just calculate, and it gives us our chi-squared calc value is 0.217, and our p-value, we can fill that in as 0.641. Okay, so remember, we are going to reject h sub 0 if chi-squared calc is greater than chi-squared crit, or if p is less than alpha. Okay, so if we compare, our chi-squared calc is 0.217 and our chi-squared crit is 3.84. Well, 0.217 is less than 3.84. If we compare our p to our alpha, our p is 0.641 and alpha is 0.05, which is greater than. So in both cases, this one tells us we're not going to reject it, and so does this one, because remember, we are only going to reject if this is greater and this one is less. Well, we're opposite on both of those. So in this case, we do not reject. So when we write this, our step 7 in this case, we say do not reject h sub 0 and can conclude. So if we are not rejecting h sub 0, that means that h sub 0 is true. So we can conclude that gender and exercise are independent. And that would be our statement of